for today, I will begin with this: what is big data and what is Hadoop? How Hadoop is playing an important role in big data and all that. Big data. We used to deal with the data. We deal with the systems like traditional RDBMS systems to store data on different workloads, right? Where we have something like transactional-based workloads, or we have analytical-based workloads. We have different systems for that. Typically we'll go for Oracle or you'll go for a SQL Server as a base for it. And the way you use the database may differ. It may be for transactional purpose, or it may be for analytical purpose. And this is limited to certain size, right? Typically if you see, it cannot scale beyond terabytes, so typically limited to certain size. Big data is something, when data size grows, not only the data size grows, there are other characteristics also that I can say or define something as a big data problem. So one of the aspects is data volume grow. You are not able to use your existing traditional system to match the data growth in the data volume and come up with some, and not able to use the data or store the data in the first place and to process the data and come up with more analytical, take more analytical approach and come up with business insights and all that. So just a few things about big data. Like if you see in my slide, this is mentioned like Walmart handles like 1 million customers transaction every day. Our Facebook handles 40 million photos for its user base. Now, all this actually some of the characteristics or some of the use cases where you see big data. How big data is actually, right? So decoding a human genome takes like 10 years. Now it can be achieved in 1 week. And these are some of the advances with big data and then the solutions. So let me go to the next slide. This is just a simple diagram which is given by IBM, and it says it says about how much data is getting generated, right? One of the main criteria for the huge data set that we see nowadays is IoT, or Internet of Things. So any device is now connected to Internet, and after the Internet has become a medium that not only connects computer, when it connects devices, the data growth has expanded exponentially. The growth has been there. So how do we? The big data is something something that you are not able to manage with your traditional system. And there are certain characteristics that I can say about big data, that you can say you can define a specific problem of data growth with the data growth, and then classify data as big data by 3 characteristics. One is volume, and one is variety, and one is velocity. And this is the 3 V's you would have seen anywhere when you actually talk about, when you actually wanted to see what is big data. There is a problem actually in the way you have huge data set, or not only it is huge, and there are other problems associated to it, like how you there are different. Volume is one angle to look at big data. Whenever the data grows beyond the limit that your traditional system cannot hold it, right? And also the arrival pattern of the data. But first I will complete the volume thing. So as you see here, Facebook in just like 500 terabyte of data, new data every day, and typical traditional system would have this as a full capacity. And now full capacity for years, right? 2-3 years of planning. They would have invested and they would have come up with a database server that would only hold something like in terabytes. But when you have to handle that within a day or within a month, there you see the traditional system cannot scale up. There is a problem with the traditional system where you have to go for something else to deal with such a huge volume. So these are some of the examples that says how volume is differentiating a data problem as a big data problem. And you have another way of looking into it with the velocity. with the click stream, I mean, when I say click stream, if you have a website and users are interacting with the website, uh, uh, generally what they do is they take the day-to-day transactional information and create dashboard. They will have this data warehouse environment, or they will have two different environments. One is OLTP and another is OLAP environment. OLAP is mainly what I'm trying to say is a data warehouse environment where the data is actually pushed there after every day, or with the time lag of 1 day to even month. I mean, 1 month data freeze and all that will happen. From the data warehouse environment, they will create the different dashboards and reports. This is what predominantly when you have a shopping site, earlier times I'm saying, when you have a shopping site or you want to see what is the performance, day-to-day activity, day-to-day revenue, day-to-day operational metrics if you want to see. But this is with respect to operational metrics. That is fine. This is giving some this is giving major information. But I want to increase the productivity. Then I have to look into the customer behavioral pattern. I mean, how the customers are interacting with my website, where they are actually, which product they are clicking, and based on that, I want to give more recommendation and all that is there. Then I have to take all the log that is getting collected in the web server when user click on a specific link. Yeah. So I was saying, like, if you have to, more than operational metrics, you also have to see how a site is actually used with the behavioral analytics of the customer, which increasing the stay time of the customer on the web page, so that the conversion can be increased. So you're pushing the customer to buy something there, and also pushing or popping up the discount or coming up with a flash of recommendations. So user generally go to the site. They also want to see other products and they want to buy related products. So how do you actually make more conversions there? So for all that, you need the log that is getting generated in the server that's hosting the web page. You have to analyze it in real time and have to go for some recommendations also. So the data, I mean, the number of users they log into the website and collecting that information and then coming up with a decision, coming up with some recommendation, and it's also very important. I mean, the rate at which the data comes and rate at which you actually propose a business insight, or based on the data you propose something, right? That is called velocity. So even it is more relevant with the stock market. I mean, in stock market, if you see the velocity or the time it takes to every second you see the stock pricing changes, and you see the numbers varying. You need to if you want to take the numbers and come up with something that is not supported with the traditional system to act as fast as the data comes in. Even with the sensor data and machine to machine, when I say it's like sense, I mean because of the internet IoT thing, now the machines or the devices are connected together. So how do we take the data? How do we, for example, I would say there is video ad-based analytics. I mean, in which case, right? The video ads will be hosted in a web page, and then users, when they click the ad, what happens is the hosting page may get credit based on the number of clicks of the ad from the ad giving company, and you want to see whether it was actually a genuine click, or is it triggered by a bot? Triggered by any activity, like you write a code and then keep on having this activity, which is not right. So how do you track you need to collect all the events of all the click events on the video, and then you have to analyze that whether it's a genuine click, and then to give the right credit to the hosting the page hosting companies. So for such things, think of the number of events that you need to collect and then to analyze. So the speed at which the events come, the speed at which you have to store that information in your database, and then to do real-time analytics on that. So all that matters here. So the traditional system, it is very tough to achieve such a analytics on the top of it. Same way with gaming and all, game systems. So also variety also makes a variety also has an important factor there. When you think of traditional system, you always deal with structured data, right? I mean, rows and columns. But nowadays, data can come in any format. I mean, it can be a JSON format, or it can be, I mean, think of photos or images, which is completely unstructured format, which is purely binary. I mean, there are three different types of data. If you classify, you can say it as a structured or semi-structured or unstructured data. Structured is purely, which is having clear identification of fields, right, with the schema information and all that. But the semi-structured is something. It does have some structure, but it is not that clearly pointed like a structured data. For example, JSON and XML. You will have specific keys in JSON which will identify specifically a field, or in case of XML, you will have these tags. These are all, I can say, as a semi-structured data. I mean, when I think of unstructured data, it's like binary data, which like photos or videos, and also complete text information, which is not having any fields, right? It's just fully text. I can say it as unstructured data. So at any time, for example, that also plays a role when it comes to, I mean, typically if you see what is all around this, it's around analytics majorly. I mean, when I say unstructured data and text completely, and what you can do with that, you can do a sentiment analysis, like you collect the data from Twitter or from Facebook and come up with a score. On how the people are and what the people are talking about your product, right? So for such analysis, you would have to store unstructured data, and then you have to do and you have to do processing of the data, and which is just not typically possible with the traditional systems where that expects the data to be more structured. So all these things, can say whether you have a big data problem or not. If you are use case, or if the problem that you're facing with the traditional system, any problem with the traditional system, then you think of going for big data. You have to see whether you have such factors there, and just for I mean, if you don't have such problems there, then it's definitely not a big data problem. You can find some solution within traditional database itself. So big data problem and then solution of a big data problem, it's not going to completely replace traditional the traditional systems. So that is going to be there. It's fully mature and well, there are a lot of players there. So it is going to be there. There are certain cases where there are big data problems, and you will go for big data solutions, whichever is there. There are some solutions. Hadoop is not only solution. I will come up. I will touch upon that.